SlopeFields. If you're watching at home, all of you watching at home, hope you printed this out first, and then we'll go through it. We have 2 days set aside for this, and this is for both days. So I don't yet know exactly when I want the stopping point to be, so we'll just kind of go for a while, and I'll assign a few, and then we'll save the rest for Monday. All right, in exercises 1 and 2, determine which graph shows the solution of the initial value problem. Okay, that may be a new term, initial value problem. But that's just a differential equation. We've done those before. Determine which graph shows the solution without actually solving the problem, which seems kind of weird. Explain why you eliminated 2 of the possibilities. Okay, so our problem is dy dx equals 1 over 1 plus x squared, and y of 0 equals pi over 2. I guess question 1 is, even without solving it, do you recognize that derivative? I hope so. What derivative is that? Inverse tangent. So if you knew what inverse tangent looked like, you could pick your right answer. The trouble is most of us probably don't know what inverse tangent looks like, which is fine. I don't expect you to know what inverse tangent looks like. So instead, let's start with the point that we know. Right? This means that the point 0 pi over 2 is on the graph. So let's check that against our 3 choices. And, well, we don't really learn anything, right? They all have 0 pi over 2. So, worth checking, but not really helpful. dy dx, that tells me the slope. So let's find the slope at a few key points, or however many points we want to find. So what do you think would be a good or an easy spot to find the slope? What x value? What's an easy one to plug in? What's always an easy value to plug in?
0.
Almost always anyway. Yeah, let's try 0. So the slope at 0, 1 over 1 plus 0 squared, would be 1. And again, that's the slope at x equals 0. So look at your answer choices, A, B, and C. Which one of those at x equals 0 has a slope of 1? Well, nearing 2 different answers. So let's sketch the slopes at 0. Now, which one of those slopes has a slope of 1? A, B, or C? B. I can't tell exactly that it's 1, but it's definitely positive. And C is definitely negative. And A is 0. So it's not A or C. And so I can't tell for sure by looking that slope is 1, but it's the only positive slope there. So it's got to be B. And again, if we really knew what the slope of, or what the graph of inverse tangent looked like, we could have picked B right away. But that's probably not most of us. All right, number 2. Let's see. Y of negative 1 equals 1. So that means the point negative 1, 1 is on the graph. And yet again, that doesn't really help us because they all have negative 1, 1. So, thanks for nothing. Where do you think we should try a slope for number 2? What x value? No takers? I'd probably try 0 again. So if I plug in 0, slope is negative 0, which is 0. So at x equals 0, which of those graphs have a slope of 0? V and C. Okay, so A's out. He does not have a slope of 0 at 0. So I need to check somewhere else. So I've got it narrowed down, but I need to try again. dy dx at, maybe we should have done -1 from the get-go, because that's the point we're concerned with. So the slope at -1, -1 is a +1. So now who's the right answer? A, B, or C? B, because at -1 there's a slope of +1. This is another one where we could have solved this, I think. What's the antiderivative of -x? It's the antiderivative of -x. Integral of -x. Start calling on people to get you to wake up. Emma, how about the antiderivative of -x? So you don't have to look at anything else on this problem. Just if I ask you to find the antiderivative of -x, what would it be? Good. Plus c. And so we could have solved this problem that way, right? You look at your graphs, and I'm pretty sure only one of those is anywhere close to -1/2 x squared. An upside down parabola would be b. So occasionally you can do it the sort of technical way of like finding an antiderivative, but it's usually easier to just check the point and check some places for slopes. All right, well, let's look at a slope field. Number 3, the slope field for dy dx equals 2 minus y is shown. Let's see if we can answer these questions, even though this is our very first slope field problem. Where would the solution curve have a horizontal tangent line? And, well, I guess let's make this clear what we're looking at here, because it's hard to see. There's the x-axis, and there's the y-axis. Let's see. Where would the solution curve have a horizontal tangent? What's horizontal tangent mean? Let's just back up and go piece by piece here. What's horizontal tangent mean? What's that? Slope equals 0. So that means dy dx equals 0. So look at our equation. If we put 0 in for dy dx, so we're really not looking at the picture yet. Where would the solution curve have a horizontal tangent? Horizontal tangent means slope is 0, so at y equals 2. And sure enough, if you look at the graph, there looks like something horizontal is going on at y equals 2. Sketch the solution curve having an initial condition of y equals 1 when x equals 0. So we're going to start at 0, 1. By the way, we're going to do 3 solutions. I'm going to put them in 3 different colors. So let's see, let's go red with this one. So 0, 1 is right there. Well, we kind of need some rules here for sketching curves in a slope field. There's going to be 2 very unofficial, informal rules here for sketching curves in a slope field. Number one, go with the flow. Like it's just kind of whatever way the current is taking you, go with the flow. Right? That's like horrible advice to high school students. Yeah, just go with the flow. It's fine. Just do what everybody else is doing. Terrible social advice, but it's how you do a slope field. Part 2 is sort of the same as part 1. Never cross a field line. Never cross one of the slope pieces. You can think of those as little slope pieces. They're trying to direct you where to go. So if I start at 0, 1, kind of go with the flow here. I'm going to go to the left first because it looks a little easier. Something like that. I can't cross that horizontal line at 2. So I think it's probably just going to asymptote up next to it. Part C, sketch the solution curve having an initial condition y equals 0 when x is 1. So 1, 0. See, is about right there. It's hard to tell without any tick marks, but or without. It's close enough. There's 1, 0. So pretty similar. Kind of just go with the flow. Part D, sketch the solution curve having an initial condition y equals 3 when x equals 0. So 0, 3. It's up there. This one's a little bit better to practice with. Again, go with the flow. Don't cross any of those lines. Let the lines kind of direct you where to go. Question E. What can be said about the long-run behavior of y? For example, does limit as x approaches infinity of y exist? If so, what is its value? So as x gets really big, what is y headed to, regardless of where we start?
0.
Careful, not 0, because here's our x-axis.
2.
It's headed to 2, regardless of where we start. Four and 5. Are the graph slopes of a function of x alone or y alone or dependent upon both? So, I don't know if this is one of those that's easy when you get it, but until you get it, maybe not. Let's say it depends on x if the slope changes left to right. Right? Like as we move left to right, if the slope is changing, then it depends on x. So in some ways this is kind of hard to see because you don't want to look at everything all at once. You just want to pick out like one row. And as we move left to right, is the slope changing? Is those little slope pieces? Yeah, it starts out negative and then less negative and then 0 and then 1 or so and then increases from there. So yes, it does depend on x. That one does. Then we will say it depends on y if the slope changes up and down. Again, it's kind of hard to see if you look at the whole thing all at once. So it's best to like just isolate one column that you can look up and down in. So cover up everything else except for that one column. Is the slope field changing as I go up and down? No. Maybe you want to pick another one just to make sure we didn't just pick one and got lucky. Like any column, the slope values are all the same. So this one's not depending on y. So that one depends only on x. See if you can answer number 5. Does it depend on x or y or both? So number 2 depends on x. No, depends on y. Yes. So it only depends on y. Now fast forward to page, I guess it's the back of the second page. Page that looks like that has 4 graphs. It's a matching page. Match the slope field with their differential equation. And one way to do that is to think about if it depends on x or y. So let's kind of think through A together here. So looking at A, slope field A, do the slopes depend on x? Yes or no? No. As you move left or right, they stay the same. Do they depend on y? Yes. So that means I need a slope field, a dy dx, that's equal to something with y in it. Some function of y. I don't want any x's in it because it doesn't matter what x is. So I look at my answer choices, and only one of them depends only on y. Which one is that? 9. So 9 is A, or A is 9, however you want to match those up. And if you wanted to check a few pieces, you could. dy dx at y equals 2 would be an easy one to check. That would be 0. So that works. If you wanted to check the slope, dy dx at y equals 0, 2 minus 0 would be 2. And so you look at your slope at y equals 0, and yeah, that looks like 2.
So, for like what you just did where it's like y equals 2, since the graph doesn't have tick marks, do we just kind of estimate where y equals 2?
Yeah. Yes. The question is, there's no tick marks, how do I know where y is 2? Yeah. You kind of have to just compare it to the others. So if there was one that was like 4 minus y, yeah, you'd have a hard time picking them out. All right, graph B. Let's do our depends on check here. Depends on x, depends on y. So does it depend on x? Yes. Does it depend on y? No. So I need to pick a slope equation that only has x in it. Whoops, there's 2 of them. So 7 or 10. So let's pick out, you know what, let's just hold off on that because I think we'll be able to tell in a minute. So that graph is either 7 or 10, not sure which yet. Maybe you know, but you probably only know if you looked at C. So let's look at graph C. Does it depend on X? Yep. Does it depend on Y? No. So that's the other one that's 7 or 10. Now, based on the specifics of 7 and 10 and the pictures that you're looking at, which one do you think matches with graph C? 7, because that looks like a sine kind of thing. It's got some oscillating things going on there. 10 is B. If we wanted to sort of verify that, we could check some points, like, I don't know, at x equals 2, the slope should be 2. That makes sense. If we wanted to check something else, like at -4, the slope should be -4. 1, 2, 3, 4, and sure enough, all those tick marked -4 have a slope of -4. So we kind of verified what we were pretty much already sure of. Well, 8's got to be D because it's the only one left, but let's go ahead and do the depends on check here.
Wait, for C, you have to do math, right? That's okay.
Yep, basically. Yep. You start to get the hang of them, and you're like, well, that looks kind of like... Although you have to be careful. It's not that it looks like sine. It's that if you integrate dy dx, what's the antiderivative of sine? Careful. Negative cosine. And it definitely looks like negative cosine. Number 10, you could do that. The antiderivative of x is x squared over 2. And 8 kind of looks like a parabola. It looks like a parabola would sort of fit in there. Now, the others you couldn't really do that with because we can't antiderivative x minus y. It's not x squared over 2 minus y squared over 2. And even if it was, that probably wouldn't even help you. Same thing with this one. Taking that antiderivative would be tricky.
Well, D kind of looks like just an X, like the slope of X.
Which one?
D.
D?
It's just like a line, isn't it?
Well, this one's a line, but the rest of this, like if we picked a point in there and followed the slope field, you get something like that. Some sort of weird looking graph. But that's because it has a weird looking dy dx. It depends on x and it depends on y. So the only one left, well, the only one left is 8, but the only one that depends on x and y is 8. Why don't you try A through D, or through D, the next set, 10, 11 through 14.
That's what I was trying to tell you.
Sorry, I didn't understand. So 13 is D. That sure does look like a B. Oh, it was 13. That's what that is. 13 is D, D is 13. Which means 14's got to be A, because that's the only one that depends on X and Y. If you pick some points on that one, another way to do this is to set the derivative equal to 0 and figure out what makes that happen. Well, that happens when y equals negative x. And so at y equals negative x, 14 is A. Or you could plot some points and see.
I just thought it works an awful lot like D from the one we did before.
Yes. Yes. All right, C or B, well, either one. So C depends only on y. So these should be easy now. Depends on y. That would be 12, I think. And if we want to figure out where the slope is 0, we can put 0 in for the slope, and we get y equals 0. So yeah, that makes sense. So 12 is C. 11's got to be B, because it's the only one left. But it also depends on X. And if we set the slope equal to 0, we would get X equals 2. And sure enough, when X is 2, all of those slopes are 0. So 11's got to be B. So those aren't too bad when you're just matching them up. All right, let's rewind back to the back of the first page as we jump all around here. One says SlopeFields classwork. We're going to build our own. Now instead of just kind of matching them up, we're going to draw our own slope field. In this section, we can solve differential equations by obtaining a slope field that approximates the general solution. Slope field, we're not worried about the rest of that. Let's draw a slope field. I don't like this graph because it's not clear like which one of those is X and which one of those is Y, but usually X changes left to right. So let's say these are our X values across the top. And Y values going up and down. So let's see, if dy dx equals y, let's see, if y is 3, then the slope is 3. What about if y is 3 and x is negative 2? The slope is 3. What about if y is 3 and x is negative 1? The slope is 3. Stop me whenever you figure out what's going on here on this row. All those are 3. Because it only depends on y. So it doesn't matter what x is, it only depends on y. When y is 2, the slope is 2. And it kind of doesn't matter what x is. Not kind of, it does not matter what x is. Well, when y is 1, the slope is 1. They're usually not this easy, but it's the first one. When y is 0, the slope is 0. Y is negative 1, the slope is negative 1. You get the idea. Now it's just like, how fast can I write a bunch of numbers in? Okay, well that's sort of my table for the slope field. Now I want to transfer those slopes to this picture. So let's start where we started on filling in the table. When y is 3, the slope was 3. So any of these points where y is 3, I'm going to do a slope of 3. Remember, slope means like up 3 over 1. Easier to look like that. So I'm going to do just a little bitty slope piece that has a slope of 3. And it helps if you've got an ID or a popsicle stick or something, not just to make a straight line, but to make the slope, or to figure out the slope of 3. So you just aim at something that's a slope of 3 away. Line up your ID or your popsicle stick or whatever. So there's my slopes of 3. My next one down is a slope of 2. It's hard to start on one where you can't have anything to aim with. So at this point, there's no point to aim with to get a slope of 2. So I'm going to save that one for later and do all the other two slopes first. Slope of 2. Slope of 2. Slope of 2. And then that last one that I didn't have anything to aim at, I can just eyeball it. All right, slope of 1. So that's an easy one. I'm just going to aim for the up 1 over 1. Slope of 0 is easy, although you can't really see it because it's right on top of the x-axis there. Slope of negative 1. Again, I don't use an ID or a popsicle stick for 1s and 0s. I can do those on my own. Slope of negative 2, I need a little more help to make sure it's the right steepness, the right slope. And then 3 is even steeper. And now I have a nice slope field drawn. Find the solution going through 1, 1. So I'm going to do this a couple times, so I'm going to use different colors. Solution going through 1, 1. Again, kind of just go with the flow. Don't cross any field lines. Like that. Going through negative 2, 0. What's that line going to look like? Do you know? Yeah, this is going to be a horizontal line at y equals 0. It's kind of a boring one. And let's do one more. Let's do one below the axis. So let's start at 2, negative 1. 2, negative 1. Something like that. So, concept, what we did is we solved a differential equation, sort of. We solved it kind of graphically without actually taking an antiderivative. And besides, we wouldn't know how to take an antiderivative of y anyway. So it's a way to get a picture solution. It's not an exact solution. It's not as nice as actually taking an antiderivative, but it gives you a picture of the answer. All right, what I want you to try for homework, let's see. Why don't you fill in the tables? I think this packet gets quicker once you get the hang of this thing. So try to fill in the tables for 2, 3, and 4. Fill in the tables for 2, 3, and 4. If you want to try to graph the picture, that's fine, but we'll probably pick up Monday and graph the pictures. So again, x is across the top, y is down the side. Try to fill in those tables, and then we'll go from there on Monday.